Alright, this is the continuation of the lecture on the ellipse. So if you remember from the previous lecture, the equation of an ellipse is modeled by the following: x squared over a squared plus y squared over b squared equals 1. And by definition, the ellipse is the set of points such that the sum of the distances from the foci is constant. Okay, so if we had an ellipse, and I change my color here. So we had focus right here and a focus right here. If we drew the ellipse, if we picked a point, let's just say this point right here, this distance here and this distance here is the same as, let's just say if we had picked one over here. So those two distances, the sum of these two is the same as the sum of these two. And if you remember from the last lecture, this right here is your major axis, the one that's longer, and the one that's shorter is your minor axis. So now let's work a few examples. So write an equation of an ellipse in standard form that has a vertex at 0, 5, and a co-vertex at 2, 0. Now what do we mean by vertex? So the vertex are the endpoints of the major axis. Okay? The vertex are the endpoints of the major axis. And I'm going to abbreviate that for endpoint major axis. Okay? The co-vertex is the endpoint of the minor axis. The endpoint of the minor axis. So again, the major axis is always longer than the minor axis. Okay, so let's move that down. So we have a co-vertex at 2, 0 and a vertex at 0, 5. It's also given in the problem that the center is at the origin. Okay, so the center is at the origin, which is 0, 0. So if we were to just draw a graph of this, a rough sketch, okay, we have the center right here, a co-vertex at 2, 0. So that means I go over 2 and up 0. So we got a point right there. And then we have a vertex at 0, 5. 1, 2, 3, 4, 5. So we have a point right here. So we know that the co-vertex right here at 2, 0 forms the minor axis, right? So we have 2 over here as well. And then the the vertex are the endpoints of the major axis. So if we go 5 units up to one vertex, we have to go 5 units down for the other one. Okay, so our ellipse looks something like that. Okay, and I apologize for the poor drawing. But again, this is what it would look like. So the standard form of an ellipse is the following: x squared over a squared plus y squared over b squared equals 1. Now, a is always greater than b. So in this case, since our ellipse, which again we'll draw here, just a rough sketch, since our ellipse had a major axis along the y-axis, we're going to have to rewrite the equation like this. Oh, sorry. A is always greater than b. So if the ellipse is oriented upward like this, it's more up than it is sideways, it's taller than it is wide, then you're going to use this equation. Whereas if it's wider than it is tall, you're going to use this equation. Okay, so we're going to use this equation, and remember the points here were 0, 5, and 2, 0. So the length of our semi-minor axis, which is A, right? Sorry, which is B, because it goes along the x-axis. The semi-minor axis is 2, so B equals 2, and A equals 5. So the equation then is x squared over 2 squared plus y squared over 5 squared equals 1, which is x squared over 4 plus y squared over 25 equals 1. So why don't we do another problem? So this time around, I want you to find the equation of an ellipse in standard form given the following information. Okay, so it has a vertex at 0, -6, and a covertex at 3, 0. And it's centered at the origin. Alright, hope you learned something new today. Thanks for watching.